Okay, so welcome to another episode of The Little Classroom That Could. In today's episode, we're going to be going through reducing balance loans. Now, reducing balance loans might take the form of a car loan, or a holiday loan, or in some instances, think of maybe, this is sort of also how a credit card works. Sort of, we'll get to that a bit later on. But essentially, thinking a bit about, you approach a bank and you want to borrow a sum of money up front to purchase something. So in this case, I said it could be a holiday, could be for a car, could be personal loan. Like for example, if your hot water system is just broken, you need about $2,000 to pay for a new system and all the associated plumbing and electrics to replace the system. Something along those lines. So the bank is, you're going to need the money up front, and then over a period of time, whether that be a year, 18 months, 2 years, you need to pay that money back to the bank. So that's why it's called a reducing balance loan. So the balance of that amount of money, so the balance of that loan, so how much you owe the bank, will be reducing over time. So think about this in contrast to chapter 7, where we were going through investment accounts, where we would pay little bits of money to the bank and they would have them invested, and our money would increase, or the total balance of that investment account would increase over time. Now we're looking at bringing the balance of that outstanding amount down over time. And once again, similar to chapter 7, we're going to be using the TVM Solver app that's on our calculator. So in particular, this class, we're going to be looking at the Texas Instruments 84 calculator, or variance upon. And to do so, we're going to need to go click the apps button. From there, we go to finance and we select TVM Solver. So just as a bit of background on how financial institutions and banks work is, so let's say we have one person, let's call them person A, approaches a bank and says, "Hey bank, I've got $600,000 I'd like to invest." And the bank says, "Yep, no worries, thank you very much. We'll put that in an investment account for you and we'll pay you, let's say, 4% per annum." Person A goes, "Yep, beautiful, thanks very much. Here's my account, here's my money, and let's sit in a long-term investment account." So what that bank then does, is the bank then goes, "Right, I've got some money, I need to pay this person A over here, 4% per annum, but how am I going to do that?" All right? But then person B walks in and person B says, "Hey bank, I'd like to borrow some money for my own purchase, to purchase something." So the bank comes in and says, "Right, well if you want to borrow money, that's going to cost you. And we'll charge you for a small loan, for a car loan. It might be something in the order of 10% or 12% for some car loans." So person B comes in and says, "Hey bank, I'd like to borrow $20,000 for 5 years to borrow a car, to purchase a car." Bank says, "No worries, that'll cost you 10% per annum. So as you pay the loan back, you're going to be charged an additional 10% per annum as you move along." So what's going to happen there is the bank's going to come in for $20,000 of that starting deposit amount of money that person A deposited in the account. Bank's going to take in, the bank's going to bring in 10% per annum, but they're only going to be paying 4%, for example, in this instance, out the other side to person A. So that's how the bank makes money, by basically organising loans from one person to the other. Right? So when you invest in money, you invest in a bank or invest in a banking institution, your money goes into a big pile and gets borrowed out. Now there are limits and checks and balances in here, and in Australia there is a certain ratio as to how much the bank is allowed to borrow out from an investment account. And I'm not 100% sure what that is off the top of my head. I think it's around 85%, but don't hold me to that. But we might use, for purposes of exercise, let's say for example, person A who brings in $600,000, the bank will only be probably allowed to borrow out, let's say for example, $500,000 of that for loans. So which is how the bank's going to make their money, remember? So that's why when you have an investment account, the interest rate will always be lower than the loan interest rates, because that difference is how the bank makes their money. So remember also you're going to have things like credit cards. That once again goes into that same borrowing pool. The bank's lending the owner of that credit card a certain amount of money so they can buy things on credit. We're going to be going through today questions 2, then 5 and 8 from this chapter. So just hold your horses and we'll be right back. Alright, so here's question 2, our example. So we're asked here, a loan for $5,000 is taken out for 3 years at 9.5% per annum interest, compounded monthly. Find the monthly repayment required to pay off the loan. Alright, from this statement and the question posed, let's highlight some critical information. So we want the amount, it's for 3 years, 9.5% per annum, and it's compounded monthly. Okay. From this information, we can start populating the fields we need in our TBM solver. So let's do that. Alright, so here our N, this will be 3 years, but compounded monthly. So the compounding periods per year we have here is 12. We're going to compound at the end, so let's assume that. Our payments per year will also be 12. The final value will be 0. The payment is what we're looking to find. The present value is minus 5,000. Remember, it's going to be minus because the bank is going to give us the money up front. The interest rate will be 9.5. And N, remember, is 3 for 3 years times by the compounding periods per year, which is 36. So if we put that in our calculator, we'll grab the answer. Alright, so now we've got our calculator in hand. We can put all this information in. Let's raise the cursor to the payment field, click alpha, and then solve. And what we should end up with is 160.16, near enough too. So it's $160.16 per payment period, which is here is per month. Okay, now for question 2 part B, we're asked to populate the entirety of this table. And this is what we've given to start with. So we're told that the principal amount to start with is $500,000 and we need to fill in the rest of it. So we know that our repayments are going to be $160.16. And that will actually remain constant for the entirety of the loan. So we can plug them in like so. So the interest, remember, however, the interest is calculated by whatever, so we can say, let's say over here, the interest of 1 equals whatever the rate, which is the balance, times by the rate divided by 12. So in this instance, it would be 5,000 times by 0.095 divided by 12, because we're told it's 9.5% interest and 12 months. So we're told that it's 9.5% interest and we're compounding monthly, so it's what we're dividing by 12. So in this instance, the interest on this particular payment will be $39.58. Now the balance, however, is going to follow this expression here. So the balance for the first month will equal the principal, what we started with at the start of the month, plus the interest, minus the repayment. So that will be $5,000 plus $39.58 minus $160.16. So when we plug that into a calculator, we end up with $4,879.42. Now we know that the principal amount at the start of the month is equal to the balance at the end of the previous month. So the principal at the second month is the balance at the first. So we say $4,879.42. So the interest, applying this same formula now, except now we're going to be plugging in $4,879.42. We're going to end up with $38.62. Now using this same equation over here, we plug these numbers in, so it's the principal plus the interest, because this is going to be how much interest we owe the bank for that particular month, minus whatever we're going to be repaying, will come to the balance, which will be $4,757.88. Once again, repeating, $4,757.88. And the interest, using the same concept again, is $37.67. Now, the principal plus the interest minus the repayment for this final cell is $4,635.37. So there we go, that's how we tackle question 2b. Okay, so now let's turn our attention to question 5. Here we have Grace, who takes out a loan of $7,000 to buy a jet ski. She'll repay the loan over 2 years at 9.9% per annum, with interest is compounded fortnightly. And what we need to do is find Grace's fortnightly repayments. So this is another job for TVM calculator. So let's look to put these numbers in. So I'm wanting to find the payment, looking at the end. The compounding periods per year is 26. The payments per year is 26. The future value we want to be 0. We want to find the payment value. The present value is $7,000, and we're going to leave that as positive because that shows that it's an income to ourselves. The interest rate, we're told here, is 9.9, and the number of periods is 26 times by 2, which is 52. So if we go into our calculator and hit the apps button, finance, TVM solver, plug in our numbers, say 52, 9.9, 7, 1, 2, 3. Our future value is 0, 26 and 26. Go up to the payment value and we hit a second bar value. So we hit alpha and enter button, which gives us a solve value. Our fortnightly repayments come out as minus $148.64. So we can write that here. $148.64. The next part of question 5b asks us to find the total amount of interest she has charged for the loan. Okay, so we know here we can say that the interest equals the total repayments minus the principal. We know that our repayments, we're going to be making number of periods, so the number of payments we're going to be making is 52 times by each repayment, which is $148.64 minus what we started with, which is $7,000. So we'll just stick that into our calculator. Minus $7,000 plus bracket 52 times by 148.64, close bracket, enter. Alright, so this will give us $729.28. So there we go. That's the total interest that's been paid, $729.28. Okay, now let us finally consider question 8. So the question posed is consider a loan of $25,000. There's a key piece of information. at 8.5% per annum, interest compounded monthly. So we need to calculate the monthly loan repayments if the loan is taken out for 3 years, 5 years, and 7 years. Okay, so let's start filling out the fields that we'll need for TVM calculator. So the compounding periods per year is 12, same as the payment periods. The future value will be 0. The payment is what we're trying to find. The present value here we're asked for is $25,000. Now we're going to leave that as a positive because that's money that we're going to gain at the start. Hence our payment would be expected to be negative because that's money that we're going to have to give away. The interest that we're asked for here is 8.5%. The number of payment periods is 3 years. 3 times by 12 is 36. So the answer that we're given for this, for the first one, is minus $789.19. So if we change this to 5 years, look at that, we need to look at 5 times by 12, which is 60, and we'll go and change that same period. So change that function, and change the information. We end up with minus $512.91. And finally we're asked for 7 years. 7 times by 12 is 84. So we're going to change that value. And now for enter, we end up with minus $395.91. Remembering these values here, the payments that we're getting out are negative because we're going to give money away. So there we go. So part B, we're asked which loan charges the least interest and to explain your answer. So the answer is that the 3-year loan we charge the least interest. This is because, remember, this principal we're going to be paying interest or whatever the present value of the loan is, we'll be decreasing over the least amount of years. So we'll be paying interest over a shorter time frame. So in this case, for the 3 years, we'd only be paying interest on that decreasing principal for 3 years as opposed to 5 years or 7 years. Hence, this value will be the least. Now, we could solve it, go and solve the maths if we wanted to. And we do that much the same as we did in the previous question. So, we could say interest equals total repayments minus the present value. So using this expression here, we can find out the interest paid for this is $3,410.84. And similarly, if we go back into our calculator and look at a 5-year term at $512.91, this will give $5,774.60. And if we press the up arrow twice, we should be able to plug in our change values, which is 7 times by 395.91. And this is $8,000, $8,256.44. Now make note that as we've determined the interest, the total repayments here, remember this is going to be little n, which is the number of years, times by 12, because it's 2 months, times by the interest, minus whatever the present value is. This value interest, remember this would be a negative value of what you see here. So this value that you'd insert in this equation has to be positive, which will give you these answers.